Hi everyone, so now we're looking at solving simultaneous equations using the matrix method. Now, I have a question here. This is actually a CXC past paper question. And hi everyone, so now we're looking at solving simultaneous equations using the matrix method. So I have a question here. This question here is actually from January 2005. CSEC past paper, math past paper. So we're going to look at this question and go through it together. So this comes from number 11, part A. So it says, write the following equations. So you have two equations, pair simultaneous equations, 3x plus 2y equals negative 1. And then we have 5x plus 4y equals 6. In the form ax equals b, where a, x, and b are matrices. Now, for simultaneous equations, using a matrix method, we're going to have one matrix multiplied by xy equals another matrix. So the first matrix we're going to get is by pulling out the numbers in front of the x and the y's. So here I have 3 in front of the x and 5 in front of the second x. So I'm going to put 3, 5, right? And then I'm going to plot my numbers in front of my y's. So then 2 and 4. That's my first matrix. And then we always multiply by x and then y. So the first matrix is the numbers you pull out and that are before your x and your y's. And then your second matrix is always the two unknowns. In this case, x and y. Let's put that equal to our second matrix is the two numbers that the two equations are equal to. So negative 1 and 6. So there we go. We have part 1, A part 1 done already. And that's where you get the 2 marks there, right? So this is A part 1. So now for part 2, it says use the matrix method to solve for x and y. Now, if you think about when you're solving simple equations in algebra, you want to remove everything that's next to the unknown, everything that's next to the letter, and move it from whatever side it's on and to the other side. So in this case, we want to leave the y and the x and the y alone here. Meaning we want to carry across this. Now, when we carry across a matrix from one side to the other side, it becomes the inverse of this matrix. Then we multiply by what was there already, negative 1, 6. So that's the method. xy is equal to the inverse of the matrix multiplied by what was already there. So now we learned how to find the inverse of a matrix from before, the videos before. So remember, just to recap, it's 1 over the determinant. Remember, the determinant is product of the first diagonal, so 3 by 4. Take away the product of the second diagonal, in this case is 2 by 5. Now we need to switch up our matrix. First diagonal, the numbers switch, so 4 comes here, 3 comes here. The second diagonals, the signs change in those numbers. So positive 2 becomes negative 2, positive 5 becomes negative 5. And then put back what we had there, the negative 1 and the 6. So let's come up here now. Let's just simplify what we have. So xy is equal to 1 over, that will be 12 take away 10. So I'm just skipping that step of writing 12 take away 10. 12 take away 10 is 2. And then we have 4, negative 2, negative 5, 3, multiplied by -1, 6. Now we need to simplify all of this now to get our x and y values. What we're going to do first, we're going to multiply these two matrices first, right? Just to make our lives a little bit easier. You could go ahead and multiply half by this matrix and multiply that by this. But to make it a little bit easier for us, let's multiply these two matrices here first. So if you need to recap, go back and look back at the video how to multiply matrices. So remember, it's row by column, row by column, row by column, row by column. First row, well, there's only one column, right? First row by the one column, second row by column. So it's going to be 4 by -1. So 4 by first number plus -2 by 6. Then we're going to do the same thing for the second row. -5 by 1, -1, sorry, plus 3 by 6. Let's simplify that there now. So 4 by -1 is -4 plus -12. Then we get -5 by -1, which is +5, plus 3 by 6, which is 18. So now let's simplify this now. Put your half outside. So -4, remember the plus and the minus will become a minus, right? And then we have 5 plus 18. 5 plus 18 will give us 23, right? So just simplify the bottom there. A half, -16, 23. And let's go back our xy here. And then we just want to simplify. A half of -16 is -8, and then 23 over 2. So my x value is -8, and my y value is 23 over 2. And that's it. So you may need to recap how to multiply matrices and find the inverse, but the method is the same for all matrices, all solving simultaneous equations using the matrix method. So go over the video step by step and try other questions.